Rachel, let us know when we're starting.
Oh, okay.
Starting now? All right. Well, welcome everybody to the SCU Maps, Augmented Reality Navigation for the SCU Campus presentation. I'm Nicolas, and I'm Brian, and our advisors over there are Professor Vassilian and Dr. Jack. To explain our project, we have to start by taking you back almost 4 years ago to when we first joined SCU. Back in fall of 2020, classes were online due to COVID. And if we needed to find one of our classrooms, it was as easy as clicking on a Zoom link, and we were in class. About a year later, though, we had our first in-person classes. And at that point, I received a schedule that looked like this, with 5 classrooms that I'd never been to before, 3 of which were in the new building that nobody had had in-person classes in. I wasn't sure if I'd be able to find all those locations on the first day in time, so I actually came to campus a little bit early to walk around the campus and see if I could find my different classrooms. And when I came to campus, I didn't see any obvious indication of which buildings were which or how I was supposed to find my classrooms. In fact, if I was looking for this brand new building, SCDI, I would never have been able to find it because it's not labeled SCDI, it's labeled Sobrato Campus for Discovery and Innovation. Additionally, this was before we learned about the numbering scheme that SCU uses on campus for their rooms, or the fact that there was an online campus map, though, as of last quarter, seems to mysteriously have disappeared. At this point, even a month into my time on campus, I recognized that I had a need for some solution to be able to navigate the campus. And through talking with other students and with faculty members, it seemed like they also had problems finding different locations on campus. So there was something that was there, but we didn't know for sure what was there. And even on that first day that I came to campus to go and see if I could find my classrooms, 3 different people asked me when I was looking for my classrooms if I could help them find different places on campus. And this happened to me every quarter since then, and not just in the beginning of quarters, but also towards the end of quarters. So there was some need here, but to get a sense of how large this need was, we decided to send out a survey to the campus community asking about their experience with navigating the campus. And the survey results were pretty conclusive. Respondents said that the current campus map solutions were insufficient and that online and physical maps and signage both had problems on campus. Additionally, using Google and Apple Maps just wouldn't work well on campus, and overall, 70% of our respondents were unsatisfied with the existing solution. So with this, we had our motivation, and this was the birth of our project. So what is our project? SCU Maps is a mobile app for iOS and Android that provides augmented reality directions to different campus locations. For those of you who are not familiar with augmented reality, it can be defined most broadly as digital elements overlaid on top of the real world. And these digital elements could be visual elements like an arrow being placed on top of a camera feed, or auditory elements like sounds being triggered when you approach a certain location, or haptic feedback like your phone vibrating to let you know of changes in the environment. The purpose of our app is to help SCU community members to be able to quickly and efficiently find different campus locations. And the user experience is that the users can then select a destination, point their phone at their surroundings in order for it to recognize where they are, and then follow step-by-step directions in the form of AR overlays of an arrow and a destination icon like you can see on the right-hand side here. This video on the right-hand side is a vision mock-up that I put together towards the beginning of our project to encompass what we wanted a final production app to look like. So why did we go with augmented reality navigation? It mainly comes down to the fact that when you're trying to correlate locations on a 2D map to their real 3D counterparts, it takes a lot of mental effort, and it's actually very prone to error. With augmented reality, our app can recognize where the user is just based on their camera feed and guide them to their destination, making it very easy to navigate. And coming back to that survey that we sent out, when we proposed our solution, 80% of our survey respondents were in favor of the solution we proposed. So with this, we started a long journey of research, design, and implementation and testing, cycling through to previous steps until we finally arrived at our MVP, our minimum viable product, which we're presenting today. So a year ago, what did we actually decide we wanted to have in this MVP? We decided we wanted to have destination selection using buttons and dropdowns, localization, meaning recognition of where you are just based on the camera feed alone, AR indicators to lead you to your destination. The destinations would only be in one building that we would support, and we would only have one-time route calculation at the beginning of your navigation, so no rerouting. The app would be watermarked and not yet available in the App Store, and all scans and data would be stored on the device. So after 1 year of development, what did we actually achieve? This is a screen recording of our app being tested in the wild. Here you can see that when you open our app, you're greeted with the ability to select a destination from over 100 120 different destinations, to be specific, 126. Here we're going to select HEFI 23D8, which is Dr. Lucas' HCI lab upstairs in the second floor of HEFI. And as we start into the navigation portion, we can see that our camera feed is being shown, and the phone is right now looking for features in that camera feed that it can recognize. And once it recognizes the camera feed features, it starts to display us arrows to guide us to the destination. Here you can see the arrows, and earlier and also towards the end of this video, you'll see the custom destination icon assets which I created. And as we go to the center of the HEFI building, you can see on the second floor, we're already getting a preview of where the arrows are going to be showing us we're going. So we have a heads up. When we start going up the stairs, the arrows start to tilt and also change direction to indicate which way we need to go. And as I mentioned earlier, this is just one of 126 different destinations that you can select, not only in HEFI Hall, but actually also in the adjacent Bergen Hall. As we go down this final corridor, you can see these last arrows fading away, which are going to reveal our bouncing destination icon, indicating that we've arrived at the HCI lab. And if we look at the nameplate next to the door, it shows us that this is, in fact, HEFI 238, just like we had selected from our dropdown. If we wanted to switch to another destination, we just press the back button, switch to a different one in the dropdown, and start navigation again to go to any of the other destinations. So checking in with our goals that we had set for ourselves for MVP, we do have destination selection. We are able to recognize where you are just based on the camera feed. We have AR indicators to lead you to your destination. And we've actually exceeded these next ones. We have destinations not just in one building, but actually in two, both HEFI Hall and Bergen Hall. And we have automatic rerouting, so if you go the wrong way, we can guide you to the next shortest path. Our app is watermarked, and all scans and data are stored on the device. So how did we actually build this? The first step is that we need to take scans of all the locations that we want to support with our augmented reality experience. And for this, we turn to Matterport. Matterport is a company that provides both hardware and software for 3D scanning. And here you can see a Matterport Pro 3 scanner on the left-hand side. On the top, it has a head that pivots around 360 degrees, capturing both color information on the front and depth data on the sides. And using this information, we can reconstruct, when you take many, many scans, a 3D model of the entire environment that you're scanning. We're very fortunate that Dr. Luca allowed us to borrow his Matterport Pro 3 scanner, and we were also very lucky to be able to meet some of the members of the Matterport management team and form a partnership with them. They've been very, very supportive of our project, and were kind enough to actually give us free export packages for some of the file types that we need for our project to work. We've taken over 1,400 scans with that Matterport scanner at this point. And while that sounds like a large number, it's not exactly clear what 1,400 means. So this is a video that we put together to give a sense of what the scanning process is actually like. On the top is the iPad screen that we're using to scan. And on the bottom is a video of the real environment that we're in. So you can see on the left-hand side, this is the scanner, that Matterport scanner. And if you look closely, the head of that scanner is rotating around to take scans, 360 degrees. I'm hiding behind the corner because anything that's within line of sight of the scanner will be in the scan. And I don't want our app to be looking for me when we're later on navigating there. So I'm hiding around the corner. As soon as the first scan is finished, it's going to pop into place on the iPad screen on top, getting rid of some of that dark area and illuminating some of the scanned area. I then move the scanner 2 big steps, 2 meters to the next scan point manually, and repeat the process. Here you can see I can't stay behind the corner, there's nowhere for me to hide, so I'm instead staying on the back side of the scanner, out of sight of the color sensors and the depth sensors on the side, and waiting for the 16 to 20 second rotation to complete. After that rotation is completed, it takes a few seconds more to align it with the scan from the previous points, which is going to pop into place now that the first one is done, the second one is done, and here it appears on the top screen. It's going to be aligning, and now we illuminate more of that dark area. And then we have to repeat this over and over. end of this video, this has been about a 20-minute scanning session, and we've completed about 30 scans. But this was a really optimal scanning situation because this was the middle of winter break. Nobody was really on campus, and in fact, the buildings were locked, so we had to get special permission to be able to come in. So we had no interruptions during this scanning session, but most of the time with people passing by or people sitting in the areas that we need to scan, we have to actually ask them to move or wait for them to pass by, which can easily quadruple the scanning time that we have here. Now, for the Sobrado building that you just saw us scanning, it actually took over 1,000 scans to complete that building's all 4 floors. And we can now take these scan points and upload them to the Matterport cloud, oops, that skipped forward, to process them into a 3D model like the one you see here of the Heafy and Bergen Hall. This is the one that we had our navigation earlier in the video. We also are able to support outdoor locations with our app. So this is the outdoor area in between Heafy and Bergen Hall and the Sobrado building. And actually you can see in there the courtyard where we're gonna be having a demo later on. A little bit more on that later. And finally, that's the very large 4-floor, 5-staircase Sobrado building, all that's explored. Now that we've taken all these scans, we need to convert them into a form that our app can actually recognize. And for this, we turn to Vuforia, a computer vision and AR framework, which we use to enable recognition of the Matterport scans in our app. With their Vuforia Area Target Generator tool, we're able to view the 3D scans that we took with Matterport, either from a bird's eye perspective or from a first-person view, and process them into the form that we need for our app. Here you can see us entering inside of the Heafy building, which you saw earlier, and if we need to, we can also select anything that we want to chop out of our scan before we add it to our app.
Now to process 3D scans, we have to actually make the AR app around it to kind of navigation task that we want to do. To do this, we use Unity, a cross-platform 2D and 3D game and app development tool that we use to glue all of our components together. These components include our custom 3D assets, our process 3D scans, and our custom building. Although Vuforia does provide us with the functionality to localize and track the user within the scan window environment we've got, we actually needed to create a bunch of code from scratch to handle the navigation and guidance tasks ourselves. One of the important aspects of this system is the nav mesh. It's short for navigation mesh, and you can see it here in the blue shaded areas of the floor. This indicates to the user, this indicates to the application which areas the user can actually walk through, and it's essential for our navigation. This is generated with the help of the 3D scanning, which you can also see. We then use this nav mesh to create a nav path, or short for navigation path, which is highlighted here in the orange line. However, the user will not actually be able to see both this blue and orange nav path and nav mesh. Instead, we use this nav path to be able to draw arrows that the user can actually follow, as you saw earlier in the video. These arrows will actually be updated in real time, as you can see here. And as we mentioned earlier too, we have also implemented rerouting features so that, let's say the user moves further away from the provided navigation path, navigation will automatically find the shortest path immediately. In this case, soon you'll be able to see once the user walks across this corner, navigation will realize there's a short path on the left corridor and go with that one and remove the other one. Additionally, we also have to focus a lot on the visual aspects of the application to make a more polished and smooth user experience. Initially, we just had the destination marker just face forwards out from the door. This made an issue where if the user approached from the side, it was quite hard to realize what that red blob was, since you're only able to see the thin side of it. But by rotating the destination marker towards the user, which is here represented by the floating camera, you're able to see that destination marker clearly, regardless of what angle you approach the destination from. Additionally, little things like the tilt of the arrows on stairs and slopes, and even the exponential growth and shrinking of the arrows animation instead of something linear, helps create a more snappy and more pleasant experience for the user once they use the app.
Now that we have an augmented reality experience, we have to create some way for users to be able to select a destination. For this, we have to build a UI, or user interface, for our app. One tool that we used for our process of UI design was Figma, a popular UI design tool. Here you can see we have a low-fidelity vision mockup on the left-hand side. This is towards the beginning of our project, and we continue to use Figma throughout our design process all the way until the high-fidelity interactive prototype on the right-hand side, where a user can actually select different destinations from the drop-down and see a real video of the augmented reality experience to get a real picture of what our app is actually looking like. With UI design in mind, We built this UI natively inside of Unity to take full advantage of all the features Unity has to offer, including support for different screen sizes, aspect ratios, and orientations.
When we build the UI natively into Unity, we're able to then combine this and integrate it with the application we already have earlier, the AR application itself. Most of the integration is done through callback functions, as you can see here. What this does is basically whenever you press a button, it'll call a function that we have created ourselves. As an example, in the destination select screen, if you press the start navigation button, it will not only navigate to the next UI pane, but also activate the AR engine and set the destination to the one you've selected on the dropdown in that UI menu. Additionally, another consideration we had to do was deal with was the battery consumption of our application. Due to the resource-intensive nature of augmented reality, we had to we don't want to enable this AR engine even when the user is not using it. So although it's quite often we need it because we have an AR navigation application, whenever there's any UI elements on top of this camera, such as when you're selecting destination or such as when you first open the app, it's not needed to have this AR engine enabled. By doing so, to do so, we first defer the initialization of the AR engine to after the destination selection is complete. This gives us the added benefit that the initial startup time is faster since we no longer need to wait for the AR systems to initialize when you first open the app and make it feel more snappy when you first open it. Additionally, not only will this be useful for the battery life, but it's also an environmentally conscious decision that we made to reduce the use of energy when it's not actually needed, as there is a significant difference in the battery usage of the AR engine. Additionally, by doing this, it also helps with the privacy side of things. By only enabling the camera when the camera feed is specifically passed through to the user gets the peace of mind that they know exactly what our application is seeing at all times. If they're in the UI section, the camera is off. And you can see this here with the green dot that Apple adds to see if the camera is on, and in AR mode it's on, but on UI mode it's the same.
So listening to our presentation so far, it might have sounded like it's a relatively straightforward process to build an app like ours, but to quote one of our awesome advisors, Professor Serlian, real projects are hard. We ran into a lot of challenges along the way building this app. Most of these challenges had to do with the fact that this is extremely cutting-edge technology. And there's very few resources and people with expertise at this university, around the country, or around the world who know how to do stuff like this. And there's no playbook that we could follow to build an app like ours. We had to do all of the research ourselves, figure everything out ourselves, and build things from scratch in order to be able to build the app that we created. Some of the challenges, the major ones that we overcame, and of course there are many, many more that we're not including here, were integration between the many different tools that we were using, especially between Vuforia, the AR tool, and Unity, the tool that we used to build the actual app, and Xcode, which was how we deployed to iOS devices. There was a lot of management of the different sort of versions that we had for those tools in order to make sure that they all would talk nicely with each other and have a smooth, streamlined flow to go through from scans to a final app. We also had some challenges with Android deployment initially, but we're very happy to say that those have been resolved, and we are able to support both navigation on iOS devices and on Android devices. We also had some challenges with scans of large buildings like the multi-floor, multi-staircase Sobrado building, which has 4 floors and 5 staircases. And that posed a lot of challenges for the reconstruction of that 3D model. But we were very happy to be able to work well with the Matterport support team in order to be able to get those issues resolved and show you the beautiful Sobrado building scan that you saw earlier. And then another issue we had was UI design. When we were doing our UI design, initially we had hoped we'd be able to bring in our Figma design directly into Unity using a tool called Figma Unity Bridge. But this tool turned out to not be sufficient for our use case, and we had to move to building UI natively inside of Unity, which actually gave us some added benefits as well. And finally, if you might have seen in the AR, we have a watermark in the AR portion of our app, which is something that we can't remove without purchasing a very expensive annual Vuforia subscription. So in order to be able to remove that watermark and actually deploy our app to the SCU community, we would need to get additional funding from the university. We want to say a huge thank you to all of the people who supported us along our long journey, to our advisors, Professor Serlian and Dr. Jack, to Lou Marzano, the Matterport management team and the Matterport support team for all of their support in our project, to Dr. Luca from the HCI lab for allowing us to use a scanner, and to Dan Ignacio for all the floor plans that we used to build our app. also want to shout out Kevin Wang. He's a mech major working on another senior design project, but he was actually volunteering on our project, and he's the one who took all of the scans of the Heafy and Bergen Hall buildings that you saw in our app. I also want to say thank you to Josh Drevlov from the Bern University of Applied Sciences in Switzerland, who was actually a member of a team that worked on an augmented reality navigation app for a hospital when they were at university. We were able to connect with him and actually figure out some of the challenges that we had. And then finally, a big thank you to our beta testers and SU supporters. I want to mention before we jump into the Q&A that there's going to be an opportunity for you to see our app live in the Serato Building courtyard at 5:30 p.m. today. And with that, does anybody have any questions?
We will now begin the 5-minute question and answer period. Presenters, please take questions from the judges first, and we will now take questions. Your 5 minutes starts now.
First of all, I think it's fantastic and so useful. Just curious, if you had more time, what do you think you would do next or in addition?
We have a lot of ideas for that. So with our MVP, we had to really make sure we chose something which would be achievable within the 1-year limited scope of senior design. But we have a lot of ideas for Target, and also beyond Target, we will have a lot of other ideas that we want to add in. So things like accessibility, features, all those kinds of ideas we have. So we've got a long list of things we would love to continue developing.
I have questions. Do you think you'll be able to update basically the apps in real time? What if there's a construction that's going to take place? So how would you go about that?
That's a very good question. So part of it is definitely we would want to make sure if there are large changes that are going to be permanent, we might have to rescan some sections and then update that inside of our app. But for some of the smaller things like obstructions in somebody's path, like a table moving, that is a little bit more tricky because different devices have different sensors on them. So with most devices, we don't have LiDAR sensors which capture depth, but for devices that do have LiDAR sensors, there is the ability to recognize obstacles, and then we'd be able to add additional code to try and recognize and tell people to go around them.
That's fantastic.
I have a question. How many people did you survey?
We had over 200 respondents, so that's about a fifth of the university. Sorry, not a fifth, 5%. Fifth is not wrong. 5%. 5%.
What sort of technical hurdles did you run into in integration between all the pieces that you had?
We actually figured out while we're integrating a few things. We actually found a bug within the Preferred engine itself, and as we mentioned earlier, due to the cutting-edge nature of the engine, it's quite difficult to find information online on what we can do to fix that. But after quite a lot of debugging, we finally were able to figure that out, and it took quite a lot of trial and error just because of that cutting-edge technology. But other than that, we also had some issues with memory management due to the large sizes of the AR scans we had. And that would be something that we would have to consider in our future endeavors if we continue to update this app. And we have a partial solution to that. And we're able to leverage on that if after this conference to build more on this application to be able to handle bigger areas. But as of right now, due to the conference, we decided to set on this MVP and work with what we have right now.
What did you say
Already
gets
beyond.
stored locally again on the, you said, what, I don't know.
Yes.
Yeah. Refresh.
Absolutely. So just to finish on the previous point, this is still exceeding our initial plan for MVP. So all of those things were going beyond things that we were trying to go and do in addition to what we had planned additionally. The things that you were mentioning were scans being stored on the device. And so the idea is that when we scale to larger and larger scan areas, we aren't going to be able to hold all of the data on one device. And so we'd have to move to loading it on the fly from the cloud. And so we can load and unload the different pieces of the map that we don't need or that we need.
Did you have random people try their phones?
We had a number of people try it
How
out.
did that go?
Went great. People liked it a lot. Yeah. And I've been hearing just from almost everybody I'm talking to that they want to use an app like this to navigate because they have so much trouble, especially Heafy, the one that we chose as our first building. It's a labyrinth. People have anybody who's been on this campus going to Heafy Hall for classes and offices, it's very difficult to navigate. So people have been very excited that we started with Heafy Hall first. Yes.
Just as a parent who gets lost on this campus all the time, I just want to say I deployment app my grandson, and luckily they have have your use case at the beginning of privacy stated, and yes. And then you would be able to come up with it, so well done.
Thank you.
Wonderful integration and storytelling as well. What would be the hurdles to scaling the solution to encompass the entire campus, or to do like, a huge shopping center or other things for indoor navigation at that scale?
Yeah, so one of the things that we're able to do with the before area target generator tool that we mentioned earlier is to actually chop the scans up into smaller segments. So we have this Brado building, which is an extremely large building. That one, we wouldn't most likely be able to support in one large area target for all devices. Some of the lower performance devices, older devices wouldn't be able to support it. So we would chop the building up into smaller segments and then load and unload depending on which one has the best tracking. So if you move from like one scan is on this side to the other side, as you move over, the engine can transition into the other scan. And that way we can load and unload memory. But additionally, as we go to even larger sizes, then we're going to start loading from the cloud instead.
All right. So we have now concluded our question and answer period. Thank you guys. Thank you to the project team for your presentation, and we'll now take a break with until 2:50, I believe. When we begin the next presentation, that'll be that time. Please know that the video stream is still live and we'll pick up any side conversations going on, so just be aware. Thank you.